elements are broadly classified into two categories, that is, metals and non-metals. The discovery of metals and non-metals show the progress of mankind towards civilization. Metals have been valuable historically, and this is apparent from the fact that the time periods have been named after the metals as the Bronze Era, Iron Age, etc. Even today, the prosperity of any country depends upon the mineral reserves present. So these days, metals and non-metals are used for various purposes, like for making the tools, machines, cars, trucks, ships, houses, jewelry, utensils, fuels, etc. Some common metals are gold, silver, lead, zinc, aluminium, magnesium, nickel, iron, etc. And some of the common non-metals are like nitrogen, oxygen, hydrogen, sulfur, phosphorus, chlorine, etc. So now we will firstly study about metals in detail. So the metals can be classified from non-metals on the basis of their physical and chemical properties. So now we will study their physical properties. So these are the visual properties which are helpful in the recognition of metals. So the first one is the physical state. Most of the metals are solid in room temperature. For example, gold, silver. So the reason for this is the atoms of metals are rigidly or they are tightly packed. One such exception is metals such as sodium and potassium are soft, and mercury is liquid at room temperature. The next physical state is luster. Substances which are shiny and reflecting surfaces are said to be metals, and metals in their pure form have luster. Example is gold, has a shiny surface. So the third physical property is thermal conductivity. So the transfer of heat from one end of the substance to the other end is known as thermal conductivity. So the metals can transfer heat from one end of their object to the other end, so they are called the thermal conductors. Example is when the utensils are heated from the bottom, the whole pot becomes hot. So it means that the heat is transferred from the bottom of the utensil to the other parts. So silver is the best conductor of heat. So the next physical property is the electrical conductivity. That is, have you ever noticed that to switch on the TV, we have to connect the wires of the TV to the plug point, and then the TV starts working. So it is just because of the thin wire of metal inside the cable which transfers the electricity that makes the TV work. So this property is called electrical conductivity. Such examples are silver, copper, iron, aluminium. So the passage of electricity is possible due to the presence of free electrons. Exceptions for this include mercury and lead. The fifth physical property is malleability. That is, metals can be beaten into thin sheets. So this property is called malleability. Examples are aluminium, gold, silver in the form of thin sheets, that is aluminum foils, gold foils and silver foils. The exceptions for this involve sodium, potassium, mercury, etc. Sixth physical property is the ductility. That is, the metals can be drawn into thin wires. So this property is called ductility. Examples are gold, silver, copper. Wires are available for us. So the copper is used as cable wires. Next, seventh property is the sonority. That is, metals produce a ringing sound when struck with a hard material. So this property of metals is called sonority, and therefore metals are said to be sonorous. So in your school you might have found a bell. So when you struck the bell with a hard material, it starts to ring. So this property is called sonority. The eighth property is strength. So metals have high tensile strength. That is, they can hold heavy weights without snapping or breaking. One such example is iron metal in different forms is used for different purposes, as in making bridges, vehicles, railway lines, buildings, etc. But the exception for this property is sodium and potassium, because they are soft metals. So with this we've understood the physical properties of metals and how do we identify them to be metals with a comparison with the non-metals. Now we'll understand some of their chemical properties of metals. So the first is the reaction of metals with oxygen. So most of the metals combine with oxygen to form metal oxide. So the metal plus oxygen will give us metal oxide. So generally metal oxides are basic in nature, and since they form bases or alkalis, that is their water soluble bases, when they are mixed up with water. Aqueous solution of metal oxides will turn the red litmus blue, which indicates that they are basic in nature. The examples are, if we see the reaction of sodium with oxygen, we'll find to form this sodium oxide, which is basic in nature. We can understand this because when this is mixed up with water, we will see the formation of a base. The next reaction we'll study is the reaction of magnesium with oxygen. So the magnesium will not react with oxygen at room temperature, but only on heating. So Mg burns in air with the dazzling white flame, producing large amount of heat, and a form of white colored compound, that is magnesium oxide, is formed. This is also basic in nature. So we can understand that magnesium will not react directly with oxygen. It will only react on heating, and Mg burns in air with a dazzling white flame, producing large amount of heat and form a white colored compound which is called magnesium oxide, MgO. So the second reaction we are going to study is the reaction of metals with water. So when a metal will react with water, it produces metal hydroxide plus hydrogen gas. So hydrogen gas is produced when the metals react with water. Second product could be metal oxide. It can either be a metal oxide or a metal hydroxide. So the highly reactive metals form their respective hydroxides, while less reactive metals will form their respective oxides. Let us see the example. The first example is the reaction of potassium with water. We can see the formation of hydroxide. So with this we can understand that it is a highly reactive metal. Therefore we found the hydroxide which is formed. The next reaction is with magnesium with water. Mg plus 2H2 will give rise to MgOH twice plus H2. Formation of hydrogen is common. Next reaction. So this reaction will further continue, that is Mg plus H2O. That is, if we give hot water, then we will see the formation of hydroxide. But if we give steam, then we'll see the formation of oxide plus H2. So hydrogen is common, but if we provide the water as hot water, then we'll find formation of hydroxide. But if we give steam, then we'll find the reaction as oxide. Next, we'll read the reaction with ion, that is 3Fe plus 4H2, which is provided as steam, will give us Fe3O4, which is iron oxide plus H2 gas will be evolved. The next reaction we are going to study is the reaction of metals with dilute acids. So the metal salts and hydrogen gas are produced when metal reacts with dilute acids like hydrochloric acid, sulfuric acid. So metal plus a dilute mineral acid will give rise to metal salt plus hydrogen gas. So the more reactive metals readily evolve the hydrogen gas from the acids, while less reactive metals slowly react to evolve hydrogen gas, which burns with a pop sound. Now we'll see the examples. So the first example is a reaction of Na with dilute acid. So Na plus 2HCl, 2Na will give rise to 2NaCl plus H2 gas will be evolved. So the H2 gas is evolved rapidly and vigorously in this reaction. The next reaction is the reaction of magnesium with dilute acid, which will give rise to MgCl2, magnesium chloride plus hydrogen gas will be evolved. Here the H2 will be evolved less readily in comparison to the previous reaction. The next example is the reaction of aluminium with dilute acid will give rise to aluminium chloride plus 3H2 will be evolved. So here the H2 will be evolved comparatively less readily. So next, fourth is the reaction of iron with dilute acid will give rise to FeCl2, iron 2 chloride plus H2 gas will be evolved. And next reaction is the reaction of copper plus HCl, and then we'll find that there will be no reaction taking place because H2 is not evolved, because Cu is less reactive than hydrogen, and so it cannot be replaced. So hydrogen cannot be replaced by copper because it is less reactive. So here we can observe that copper will not react with dilute hydrochloric acid even on heating, but it will react with sulfuric acid, which is concentrated to form CuSO4 plus SO2 plus 2H2O, which is concentrated. The next reaction we are going to study is a reaction of metals with salt solutions. Reaction of metals with salt solutions. So more reactive metal will displace the less reactive metal from its salt solution, and this type of reaction is called the displacement reaction. Here we can see that M1 is a more reactive metal and we have the salt solution of M2. So here we can observe that M2 is a less reactive metal. So M2, we have a salt solution of less reactive metal and we have a more reactive metal. So with this we can understand that the more reactive metal will replace the less reactive metal from its salt solution, and so at final we can find the salt solution of the more reactive metal. So this is the overall displacement reaction. One such example we can see is Fe plus CuSO4, which is blue in color. So Fe is a more reactive metal. So after the reaction, we can observe that FeSO4 and Cu as a precipitate will be formed, and this is green in color. So after adding iron to the blue copper sulfate solution, the blue color fades as green ferrous sulfate solution is formed and brown bits of the copper forms as a precipitate. The next reaction is Mg plus CuSO4, this is blue in color, will form MgSO4 plus Cu, colorless. So on adding magnesium to the blue copper sulfate solution, the blue color will fade as a colorless magnesium sulfate is formed and brown bits of copper metal forms as a precipitate. So all these metals and their metal salts follow the trend of the reactivity series. So it is important to learn the reactivity series. So the next reaction we are going to study is the reaction of metals with bases. So metals like zinc, aluminium, etc. react with bases like sodium hydroxide, potassium hydroxide and liberate hydrogen gas along with the formation of salt. So we'll see one example. Zn plus 2NaOH will give rise to Na2ZnO2 plus H2 gas. So this is sodium zincate. So with this we've understood the chemical properties of metals. Now we'll understand the term called corrosion. So the process of degradation of the metal surface by action of air, moisture or a chemical is called corrosion. So mostly metals corrode after being exposed to moist air and form oxides, carbonates, sulfates or sulfides. So first let us study with an example. So the first example is iron particles get coated with a reddish brown powder when left open in moist air for a long time. So this process is commonly known as rusting of iron. So rust is a hydrated ferric oxide. Rust is a hydrated ferric oxide. So the rusting of iron is a continuous process which ultimately eats up the whole iron object. So now we'll see the reaction. The reaction is 2Fe, which is solid, plus 3/2O2, which is gaseous, plus XH2O, which is liquid, will give rise to Fe2O3 dot, which is rust, where X represents the number of water molecules. So we can write the overall reaction as follows, that is Fe plus 3O2 plus XH2O will give rise to 2Fe2O3 dot XH2O. So to prevent corrosion, the metal articles are generally painted. So next example of corrosion is the loss of luster of silver and copper by gaining black or green coatings of silver sulfide and basic copper carbonate respectively. So the reactions are as follows. So for silver, Ag, which is solid, plus H2S, which is gained from the air, will become Ag2S, which is solid, which is silver sulfide plus H2 gas will be evolved. For copper, we have the reaction that is CO2 plus O2 plus H2O. All these which are obtained from air to form CuCO3 CuOH twice. This is the basic copper carbonate, which is green in color. So the more reactive metals will corrode more easily. With this we have completed the corrosion. Now we'll understand the uses of metals. First, metals are like iron are used in machinery. Second, metals like aluminium are used in cooking utensils, wrapping food, etc. Mercury is used in thermometers. Fourth one, gold and silver are used in making jewelry. Fifth one, copper is used in the electric wire. Copper is used in electric wire. So with this we have completed the metals. Now we'll study about non-metals. So non-metals are usually opposite to metals in their characteristics. The important physical properties of non-metals are, the first one is physical state. So non-metals are found in all the three states of matter. So out of 18 non-metals, 6 are solid at room temperature, 1 is liquid in room temperature, and 11 are in gaseous state. So next physical property is hardness. So non-metals are generally soft. The reason is due to their non-rigid packing of their atoms. The exception for this is diamond, which is the hardest natural occurring substance. The third physical property is luster. Diamonds are non-lustrous. Fourth property is ductility. But there is an exception for luster, that is graphite and iodine, which are lustrous in nature. And non-metals do not show any ductility. Fifth property is conductivity. Non-metals act as insulators both thermally and electrically. The reason is the absence of free electrons. And here also there is an exception, that graphite is a conductor due to the presence of free electrons. The sixth property is malleability. Non-metals are non-malleable. And the seventh property is strength. Non-conductors are not as strong as metals. And the eighth property is sonority. Non-metals are non-sonorous. With this, we have completed the physical properties of non-metals. Now we'll go and study the chemical properties. So the first is the reaction of nonmetals with oxygen. Nonmetals form respective non-metallic oxides. So the non-metal plus oxygen will give rise to non-metallic oxide. Non-metal oxides are generally acidic in nature because they form acids on mixing in water. An aqueous solution of non-metal oxides will turn the blue litmus red, which indicates that they are acidic in nature. So some of the examples are copper plus oxygen will give rise to CO2. But if there is no sufficient oxygen, then carbon will react to form carbon monoxide. So the CO will not form acid or a base in water. The next reaction is reaction of phosphorus with oxygen, which will form phosphorus pentaoxide, which is an acidic oxide. So the next reaction we are going to study is the reaction of non-metal with water. So generally non-metals do not react with water or steam. So sulfur plus H2O will not give us any reaction. Copper plus H2O will not give any reaction. The third one is with the reaction with dilute acids. So non-metals also do not react with dilute acids. The fourth one is reaction of non-metals with bases. So the reaction of non-metals with bases is very complex. Now we have completed the chemical properties. Now we'll move on to the uses of non-metals. Uses of non-metals. The first one is non-metals such as oxygen is essential for our life. All living beings inhale oxygen during breathing. Nitrogen and phosphorus are used in fertilizers to enhance the growth of crops. Chlorine is used in water purification process. Bromine is used in purple colored solution which is applied on wounds as an antiseptic. And non-metals such as sulfur are used in crackers. With this we have completed the non-metals as well.